Good morning, everyone. My name is Saritha Kumari. I'm working as assistant professor in the department of EEE Aeronautical Engineering College, Dundigal, Hyderabad. Here, I'm going to give lectures on subject basic electrical engineering. Today, my first lecture. The topic is here. I'm going to start module 1. So this module 1 is about basic electrical circuits. Basic definitions. This module mainly deals with basic concepts, Ohm's law, Kirchhoff's law, and then equivalent resistance of networks, source transformation. And these are the various techniques, various analysis, this module 1. And along with this module 1 also covers single phase AC circuits, that means related to AC. Basically what is meant by alternating signal. Related to that, its RMS value, average value, and its form factor, peak factor, and related parameters like impedance and admittance. So first, I'm going to talk about what is meant by electricity, then basic definitions, then Ohm's law. So electricity is defined as it is the flow of charges from one place to another. It is a physical phenomena. So it is defined as flow of charges, means especially exactly to say flow of electrons from one place to another place. These electrons can flow through any material but doesn't so more easily in some material than in others. So based on basically because materials are classified as conductors, semiconductors and insulators. So conductors means electrons in conductors, electrons flow very easily. Examples are graphite, human body, and then semiconductors. In semiconductors, only few electrons are available. So these few electrons can be made to flow under certain circumstances. So examples are silicon and germanium. And then insulators. Insulators means here electrons, free electrons are very few electrons. We can say no free electrons are available for the electricity to flow. That's why it is mentioned as electrons flow with great difficulty. Examples for this insulators are plastic and fiber, glass, cloth and wood. And now coming to the basic concepts. What is meant by charge, what is meant by current, voltage, power and energy, and the basic terminology of circuits. So this is a structure of atom. In the structure of atom, in the center we have neutrons and protons, and protons are positively charged particles and neutrons are no charge, and electrons are in the outer part of the atom. They are electrons, they are negatively charged, and this is how the structure of atom. And here the charge of the electron or neutron. Here the electrons are negatively charged and protons are positively charged. So positive charge value is 1.6 into 10 power minus 19. Each proton has and each electron has minus 1.602 into 10 power minus 19 coulombs, and neutrons have no charge, so 0 coulombs it is mentioned. And here the law of conservation of charge, it is defined as charge can be neither created nor destroyed, but it just transfers from one circuit to another circuit. So always net charge in any circuit is 0. That is the law of conservation of charge. So first definition of current. This current is defined as the rate of flow of electrons in a conductive or semiconductor material. So current is defined as rate of flow of electrons. Sometimes they also say rate of flow of charged particles. So charged particles means electrons. It is measured by, and this current is measured by number of electrons that flows at a point in unit time. And mathematically it is given as, current is given as charge by time. Okay, so rate of flow of electrons. So that's why charge by time. So that means I equal to, current is denoted with letter I. If it is a DC current, denoted with capital I. So Q, charge means Q denoted with letter Q. Time is T, small t. Other expression for current, they also show it as dq by small I equal to, small I means AC current. I will tell what is DC current and I will AC current. So small I equal to dq by dt. Now that means rate of change of charge over rate of change of time. So current definition is also mentioned like that. Now let us a small example on this to calculate the current for a given charge and for a given time. 5 coulombs of charge flows past a given point in 2 seconds. How many amperes of current is flowing? So for this, to calculate this current, charge 5 coulombs of charge is given and time is 2 seconds given. So I equal to Q by T means 5 by 2, that means 2.5 amperes. Now, what is DC current? What is AC current? So, if the current, DC current means if the current doesn't change with time but remains constant. It doesn't change with time. Its magnitude doesn't change with time. It remains constant. Then it is called direct current, DC. Now, AC. A time varying current is represented by letter small I, and it is defined as a sinusoidal current. Okay, a common form of time varying current is a sinusoidal current or alternating current. That means a current whose magnitude change continuously with respect to time. Okay, that is called alternating current or sinusoidal. They also say commonly used signal for alternating signal is a sinusoidal signal, sinusoidal voltage wave or sinusoidal current wave. Okay, that is the AC signal. Now, the units of current are amperes. So this is how a DC current is shown. Okay, graphically. First one, figure A shows the direct current whose magnitude is constant. So that is a DC current. The first one, figure A. So whose magnitude is constant with respect to the time and it is denoted with capital I. And the figure B shows the AC current, alternating current, whose magnitude is continuously varying with respect to time. So, and it is denoted with small I. Next, voltage. What is meant by voltage? Here, to move an electron in a conductor in a particular direction requires some work or energy. So, this work is performed by by an external electromotive force. They say that it is EMF, typically represented by battery, which is shown here in figure. So here let's see in this figure, this is the battery plus minus. This symbol shows here this is a battery, and here it is connected across a conductor. So in a conductor, we know that there are electrons. So this, to move these electrons, this battery should be connected. So that is nothing but here external force. This battery is nothing but here external EMF, external electromotive force. So this is known as voltage or potential difference. Okay. Now based on this, so voltage is defined voltage is defined as work over charge. To move a charged particle, or that means electron, work is required. So voltage is defined as here W by Q. Okay, voltage is denoted with letter V. So here, based on that, example is given: if 70 joules of energy is available for every 30 coulombs of charge, what is the voltage? So V equal to W by Q. Here, the work, that energy is value given as 70 joules over 30, which comes 2.33 volts. Next, voltage between 2 points. So we know what is a voltage. Okay, definition of voltage. Now this voltage between 2 points. So it is defined as uh, between 2 points. The voltage given between 2 points. So it is mentioned as like this. The voltage between 2 points, let us say A and B, small a and small b, here you can see in the figure, small figure. So in an electrical circuit is defined as, is mentioned as like this: energy or work needed to move a unit charge from terminal A to point B. Okay, so now mathematically it is given by VAB equal to dW by dQ. dW by dQ. Now here W is the energy in joules, Q is a charge in coulombs. Okay, and therefore then voltage V is voltage is denoted with letter V and units are volts. Then it is given by joule by coulomb. It is also written as joule means Newton meter, so Newton meter over coulomb. Now this voltage between 2 points, they also say that potential difference. It is mentioned as like this: energy, it is the energy required to move a unit charge through an element. It is the energy required to move a unit charge through an element, and it's measured in volts. Now next definition: power and energy. What is meant by power? So power is defined as rate of change of energy. Power is defined as rate of change of energy or rate of change of work. Energy means work. So it is denoted by P. Then the mathematical expression is given as P equal to dW by dt, or simply we can say W by T. So rate of change of energy, rate of change of work done. So W by T, which is also nothing but dW by dt. So here it is written as, look at the second step, dW by dt is written as dW by dQ into dQ by dt. So we know that dW by dQ is voltage V and dQ by dt is current. So power P is also given as product of simply voltage and current. Product of voltage and current. So that what it is mentioned as, the power absorbed or supplied by an element is a product of voltage across the element and the current through it. So that is the other definition for power. And this power is measured in watts. Okay, it is measured in watts. Now, energy. What is meant by energy? So energy is defined as the capacity to do work. Okay, it is a capacity to do work, and this energy is given as power multiplied with time. Power multiplied with time. So its units are given as, we know power units are watts, watt, hours. Okay, so watt, hours. So conventional units of energy. These are the conventional. Of course, we know time usually we say in seconds, but energy units. Conventionally, units for energy they use in hours. Time is mentioned in hours. So watt hours. Now example, a small example to calculate power. What is the power in watts? If energy equal to 50 joules is used in 2.5 seconds. Is used in 2.5 seconds. So power is equal to energy by time. So energy is given 50 joules over 2.5. So it gives 20 watts. Next. So these are the basic terminology. These are the terminology of electrical circuits. We use in a while studying in electrical circuits. These are the words commonly we come across. First is what is meant by circuit element. Circuit element is defined as it can be any electrical component such as resistor, inductor, capacitor, etc., which can be connected to other components. That is nothing but circuit element. Okay, this is nothing but any electrical component, resistor, inductor, capacitor, which can be connected to other components in the circuit. Now, next branch. What is meant by branch? It is a single path containing one simple element. It is a single path containing one simple element which connects one point to another point, any another point in the circuit. That is branch. Next, active element. Active element means in the name itself it is there, it is active. Okay. So generally it is defined as like this. An element which is a source of electrical energy. It is a source of electrical energy or ability. It have the ability to increase the level of a signal. Okay, that is how active element is defined. It is a source of electrical energy. Other words, which generates electrical energy, which supplies electrical energy, or it have the ability to increase the signal level. It is called active element. Examples: voltage source, current source. Okay, examples are a voltage source and a current source. Next, passive element. So it is contradiction to active element. Passive element means an element which either absorbs means consuming. Okay, consumes or store electrical energy. Electrical energy is called passive element. So as I said, passive means it is consuming, simply consuming or absorbing, or it stores also. Okay, examples: resistor, okay, inductor, capacitor. These are passive elements. Okay, whatever the circuit elements, they are passive elements. RLC. Next, linear element. What is meant by linear element? So an element in which the voltage current characteristics, the VI characteristics are linear. That is called linear element. An element in which the relation between voltage and current, if you draw the characteristics between voltage and current in a particular element, if its characteristics between voltage and current are linear, then we call it as simply linear element. Examples for linear element are resistor, inductor, capacitor. Next, non-linear elements. It's a contradiction to the linear element. An element in which the VI characteristics are not linear. Example for this nonlinear elements are diodes. Diode is a nonlinear element. Light dependent resistors and thermistors. Okay, this thermistors, light dependent resistors This comes under nonlinear elements. Now, unilateral element. Unilateral element means, okay, in the name itself it is there. It is the one. It is the one that doesn't exhibit same VI characteristics, same voltage current characteristics when the direction of flow of current through it is reversed. That means it is unidirectional element only. Okay, so it doesn't have same voltage current characteristics when its direction, when its polarities are interchanged. Okay, so that is nothing but unilateral element. Example for it are diode. Good example for this is diode. And bilateral element. It is contradiction to unilateral element. So bilateral element means in the name itself it is there. An element that exhibits same VI characteristics, means same voltage current characteristics when the direction of flow of current through it is reversed. That means even we change its terminals in a circuit, it doesn't change its VI characteristics. Okay, even though we change its terminals in the circuit, okay, wherever it is connected in the circuit, its VI characteristics are not going to change. It has the same characteristics. Examples for this bilateral element are RLC, resistor, inductor, capacitor. Next, what is meant by junction? What is meant by node? Okay, junction means it is a point in a circuit at which two or more elements are connected. Two or more circuit elements are connected. That is called junction. A point at which two or more elements are connected. Next, node. What is meant by node? It is a point at which more than two elements are connected. See the basic difference. Node, when we call a node, means a point in a circuit, a point where more than two elements connected, then it is a node. Okay, junction means if simply two elements are connected, that becomes junction. Okay, junction means minimum two elements is sufficient. Okay, more elements also there. Okay, minimum two or more elements, that is called junction. Now next one, what is meant by mesh? Okay, what is meant by mesh? So mesh means it is a loop. Okay, so first look, loop means it is a closed path. Okay, so mesh is a closed path which does not contain any other loops within it. Mesh means it is a closed path. Okay, it is a loop that does not contain any other loops within it. But loop means, okay, loop means it is a loop which may have other loops or meshes inside. Okay, so loop means it is a loop it may have other loops or meshes inside. But mesh means it's simply a loop that doesn't contain any other loops inside. Okay, that is mesh. Now, what is meant by circuit? What is meant by network? Okay, a small difference between them. So, electrical circuit. What is meant by electrical circuit? What is meant by electrical network? Electrical circuit is an interconnection of interconnection of two or more simple circuit elements. Okay, resistor, inductor, capacitor linked together in a closed path so that current flows continuously. So circuit means, electrical circuit means there must be a closed path. Okay, interconnection of two or more elements with a closed path so that current flows. Here we can see in the figure. So battery is there, and battery to a battery, a resistor is connected through a wire. Okay, so here we can see the closed path, so current flows in the resistor. Here we can see the practical example. A lamp is connected. Lightning lamp is connected to a battery through a wire. Okay, so it is closed, the wire. So current flows to the lamp so that lamp glows. Now, what is meant by network? Electrical network means it is simply interconnection of two or more circuit elements. So, network means interconnection of two or more circuit elements. There is no closed path. So, simply if any connection of elements, number of elements connected, we can say that is a network. We can call it as a network. Okay, but when we call it as a circuit, there must be a closed path. When there is a closed path, then only we call it as circuit. Okay, next. Okay, Ohm's law. So, Ohm's law, what is this Ohm's law says? So, see that this Ohm's law is named after the German mathematician George Simon Ohm, who first stated it in 1827. Okay, so what Ohm's law is given by this German mathematician whose name is George Simon Ohm. Okay, now it states that what it says. It states that at constant temperature, the potential difference across the ends of a conductor is proportional to the current I flowing through the conductor. Okay, so this Ohm's law states that current at constant temperature. Okay, so know that at constant temperature, this Ohm's law is given stated under this condition. At constant temperature, the potential difference, that means voltage, applied across the ends of a conductor is directly proportional to the current I flowing through the conductor. Okay, so mathematically it is expressed as V proportional to I. Mathematically, this Ohm's law can be stated as V proportional to I. So here a proportionality constant is resistance. So we can write it as V equal to R into I. R is a proportionality constant. R is a proportionality constant. And it is called resistance of the conductor. Okay, R is the resistance of the conductor. So from above it is written as R equal to V by I, V by I. Now, so here, so it is mentioned in equation 1, R is a proportionality constant and is a resistance of the conductor, and its units are ohms. Resistance units are ohms. Okay, denoted with ohms, denoted with the letter like this. Now, okay, there are certain limitations for this Ohm's law. This Ohm's law could not be applied to networks containing unilateral elements. It cannot be applied. Okay, so to unilateral elements, that means diodes, example, and non-linear elements also. Now, what are non-linear elements? Again, diodes, light dependent resistors, thermistors. Okay, these are the limitations of Ohm's law. Next, continuation. Using a DC source, Ohms achieved the experimental verification of his law. Okay, so initially Ohm achieved this his statement, Ohm's law verification using experiment. Okay, now using a DC. Now later experiments with time varying sources showed that this law is also valid when the potential difference applied across linear resistance is time varying. So they verified this Ohm's law with the time varying source also, AC signal, AC source also. Okay, so that's what it is. Okay, mentioned. So later they verified this Ohm's law with AC source, AC supply also, time varying source also. Okay, so that is what. Now in this case, the Ohm's law is given by V proportional to small v proportional to small I, right? Small v and small I are the AC voltage and AC current. So in that case, V equal to small v equal to capital R into I. R is a proportionality constant. Okay, which is a resistor, a resistance of the conductor. Now, so where small v and small I are instantaneous values. Okay, in specific. Okay, not only, yes, they are the AC voltage, AC current, but exactly to say instantaneous values of, okay, voltage and current. Okay, so what is meant by this instantaneous value? We come across in AC uh, whenever we study about in first module only, AC signal. There we come across this instantaneous value. What is meant by this? But this is a word we see in AC. Okay, instantaneous value of potential difference and current respectively. So that is about Ohm's law. So now there are few problems, example problems based on Ohm's law. See that first problem: a small light bulb is connected to a 6 volts battery and draws 2 amperes of current. What is the net resistance of the bulb? Okay, so small bulb, 6 volts battery, okay, connected to 6 volts battery and drawing 2 amperes current. Then they're asking what is the resistance. So we know that from Ohm's law, okay, R is equal to simply V by I. So 6 by 2. So here we get 3 ohms. So R value is 3 ohm. Okay. Now, so here sub voltage is given in volts, current is given in amperes. So directly we can calculate resistance, we get in ohms only. But sometimes the units are given millivolts for voltage. Okay, and amperes current also given, they may give in milliamperes or microamperes. So we need to look at the units. Okay, so 1 milliampere means 1 into 10 power minus 3 ampere. 1 microampere means 1 into 10 power minus 6 ampere. So while substituting, if the values are given in milli or micro, so we need to be careful at the time of substitution, okay, to get the correct answer. Okay, next, second problem. A motor with an operating resistance of 32 ohms is connected to a voltage source. The current in the circuit is 1.5 amperes. What is the voltage of the source? Okay, see here motor resistance 32 given and current in the circuit also given. Then they're asking voltage of the source. So direct problem, it is also a direct problem based on Ohm's law. So just only the thing is the practical application we have to, I mean, from this problem we are understanding. Okay, the motor connect with its resistance, okay, and 32 ohms connected to the voltage and the current in the circuit, so that the current flowing in the circuit is 1.5. So then they're asking what is the voltage of that source. So then we know that from Ohm's law, V equal to so that's what given data I have written first. Okay, R equal to, okay, 32 ohm, I equal to 1.5 amp and V equal to how much? So V equal to I into R, 1.5 into 32, that means 48 volts. Now next problem, determine the amount of current going through 50 ohm resistor with a voltage of 120 volts. So here, look at the given data. Okay, they're asking determine the amount of current through 50 ohm resistor with a voltage of 120. Okay, so with respect to a resistor, they have given current flowing. Okay, um, current flowing. Sorry, they're asking current flowing through the resistor value 50 ohm and the voltage is 120. So uh, first note down the given data. Resistance is equal to 50 and V equal to 120. So I equal to V by R, 120 by R. So how much it is? 120 by R. So it gives 2.4 amperes. 2.4 amperes. Okay, so these are the just small examples based on Ohm's law to understand better understanding of Ohm's law and its applications, right? So means motor, with respect to a motor, second problem is mentioned and first problem is lightning bulb. So those are the good examples based on Ohm's law. So I hope you understand. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.